Okay, so we're going to begin section 3.2 now, which is truth tables. So what is a truth table? Well, recall from section 3.1 that we were looking at mathematical statements. So a statement that can be assigned a value of true or false. So as an example, it is raining. Okay, so this can have two possible truth values. It can be true if it is raining, or it can be false. So two possibilities. Let me put this in quotes. Two possible truth values. Okay. And just true or false, by the way, just true or false, right? Those are the only true truth values. Now, what if I gave you another statement like, it is sunny outside? Okay, also two possible truth values. True or false. So if I combine these statements, because we learned some ways to combine statements last time, we learned about and statements, or statements, and implications, or if-then statements. We also learned about negations, but the way to connect two statements is with and, or if-then, an implication. So for a statement like that, how many possibilities are there going to be when we put these statements together? So, for the sake of convenience, let's name this statement P and this statement Q. And let's consider the statement P and Q. Okay. Now consider how many ways are there, how many possibilities, how many possible combinations of true and false are there for P and Q? Well, how about I make a table? A truth table. Okay, so I'll put P in a column, Q in a column, and let's just start with that. Okay. Now I am leaving space over here for the statement P and Q, but we'll talk about that in a second. Right now we're just going to talk about the possible combinations for combinations of true or false underneath P and Q. So first of all, I know that I could have P being true and Q being true. Okay. I could also have P being true and Q being false, right? So this truth value of true for P can either be lined up with a truth value of true for Q or false for Q. And now you might see now that there will be two more, one being false true and one being false false. So there are four combinations. Okay. What if there were three variables? P, Q, and another statement. P, Q, and R. So three variables, how many combinations would there be then? There would be 8. So the number of combinations, in other words, the number of combinations here, in other words, the number of rows in our truth table, so I'll say number of combinations, by the way, is equal to number of rows in our truth table, is going to be equal to 2 to the power of n, where n is number of statements, which I'll call, since I've named them as letters, I'll call them variables. So here I had two variables, P and Q. 2 to the second power is 4. So there are 4 combinations, there are 4 rows in my truth table. Okay. All of this was just a discussion of how many combinations you should expect and where they come from. All right, but now let's actually get into the meat of what this section is really about, which is the truth values of AND statements, OR statements, and implication statements. In fact, I'm going to go ahead and copy this table onto a new piece of paper, just so I have more room to work. So I got true, 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 false, false, true, false, false. Okay, so here's where the logic is going to come in. We need to discuss what will the corresponding truth value for P and Q be in each of these combinations. Okay. So consider what P and Q were. They were, it is raining and it is sunny outside. So for the first row, let me write down P and Q, okay? Just like we did from section 1. It is raining, what is it? It is raining and it is sunny outside. So this is P and Q. So that's exactly what this says here, P and Q. Okay. So I'm gonna give you 4 different scenarios with corresponding to these truth values for each of these statements, and you should ask yourself if the end result is a true or a false statement. And the way I like to phrase it sometimes is answer if I am lying or not in each scenario. So in scenario 1, which will correspond to row 1 here, it's true that it's raining. So let me say, it is in fact raining outside. So that part's true, and it is in fact sunny outside. So you look outside, and it's raining and it's sunny, so it's like one of those weird times where it seems like happens in Alabama a lot actually, where it's somehow it's like bright and sunny outside, but it's also pouring down rain, like a rainforest. So you look outside, and now I say this statement. I say to you, I look at you and I say, it is raining and it is sunny outside. Would you say I was telling the truth or am I lying? Logically, I'm telling the truth, right? Both parts are true, so I'm not telling a lie. Alright, scenario 2 here. It is, in fact, raining outside, so the first part is true. It is not sunny outside. So this is a typical rainstorm where it's not sunny outside and it's raining. And then I look at you, and I look out the window, and I look back at you, and I say, it is raining and it is sunny outside. Would you say I was lying or telling the truth? You would say I was lying, right? Because the second part of my statement is false, but I connected it with and, right? Oops. So now we're starting to see how and works as a connector for 2 statements. It requires that both pieces are true. Because if I look outside and I say it is raining and it is sunny outside, but it's dark outside, then I've told a lie. And by a similar argument, for number 3, here, let me do this. If I said, or not if I said, if it is, in fact, if it is not raining outside, so this corresponds to row 3, where the first statement is false. It is not raining outside. And the second part, it is sunny outside, so this is just a normal sunny day. and then I look at you and I say this statement. It is raining and it is sunny outside. Well, part of the statement is right, but the first part is not. So I've told a lie. Okay. And then for the fourth one, clearly if both statements are false, then the result should be false. So I think this is clear. Okay, so our conclusion is that an AND statement, what can we say, requires both pieces. Well, could be more than two, but typically we'll only deal with two at a time. Requires both pieces to be true in order to what? In order to yield a value of true. Whatever. Okay. Okay. If you don't like this example, consider this. What if let's see. Okay. What if I ask you to let's see. So let's say I ask you to go to the gas station to get me a snack and a drink. So I give you $5 and I say, get me a candy bar and a Coke. And then you come back and you only have one of my items. You only have the Coke. Well, then I'm going to say, well, what the heck? You didn't do exactly what I asked. You should give me some of my money back, right? Or if you only got the candy bar and not the Coke, see, then you would have, quote unquote, lied, right? You would have not completed the entire statement. Both pieces need to be true in order for the AND statement to be true. Now, real quick vocabulary word, an AND statement is called a conjunction. It's called. That's just a vocabulary term. You should memorize this table. Well, you really don't need to memorize it if you understand it, but you're going to be using this a lot, along with the other two tables for OR statements and for if-then statements. Excuse me. All right. Let's talk about OR statements now. Consider P or Q. Okay, let's make a truth value. Now, I'm not going to ask the same question of how many possible combinations are there going to be for the number of rows, because we already know, right? There's two unknowns, or two variables, so there should be 4. Oh, you know what? I didn't do those lines last time, so I'm not going to do that. There's P, and there's Q, and then there's P or Q. Okay, and there will be 4 combinations here, and I already know them. These 4 combinations have nothing to do with the end result here. These are just all the possible combinations for true and false for these two statements. So I've got my double true, my true false, my false true, and then my double false. Alright, so let's consider P or Q. So I'm going to do a similar thing where I'm going to give you 4 scenarios, and we'll probably go through this a little bit quicker. We'll use the same statements. So let's say it is in fact raining outside. Now recall that this statement will be it is raining or it is sunny outside. So first statement, it is raining outside, is true, and it is sunny outside. So the statement that we're trying to measure the truth value of here has an or connecting it. So I'm going to say, this is the actual scenario. So just consider a scenario where it actually is raining outside and it is sunny outside. Both are happening. And then I look at you and I say, it is raining or it is sunny outside. That is true. That is true. Okay. So if you're not convinced that that should be true, consider the example I gave a moment ago with the gas station snack trip. So if I gave you some money and I said, go to the gas station and either get me a Hershey bar or a Snickers, and then you came back and you had brought me both, I would be happy, right? You would have satisfied the conditions that I asked you to satisfy. Because you got both, right? You did better than you needed to. Okay? So condition 2, or rather scenario 2. First statement is true, so it's raining outside. Or I think the statement was just, it is raining, so I'll just leave it as that. It's implied outside, obviously, right? It is raining, and it is not sunny outside, because the second one is false, right? So it is not sunny outside. Okay, so I look at you and I say, we look outside and it's raining and it's dark outside, and I say the statement, which is, it is raining or it is sunny outside. I would be telling the truth, right? Because one part of the statement is true, right? That's the difference between an and or an or. An and is very restrictive. It requires both statements to be true, whereas an or will allow either statement to be true. So the third one will be true by a similar logic, right? So consider the gas station snack example again. If I said, go to the gas station and either get me a Hershey's or a Snickers bar, and you come back with only a Hershey's bar, you satisfied the conditions, right? You satisfied the statement because I said this or that. And what if you came back and you only had a Snickers bar? Well, I would still be happy because you satisfied one part of the statement. That's how an or works. Now, if you come back and you don't have anything, that's not going to be good, right? That's false. So the fourth scenario with our P and Q as we've written them, which I can't keep all on the same page here. Okay, I'm going to write it and then I'll scoot back down. It is not raining. It is not sunny. So I look at you and I say, it is raining or it is sunny outside, but neither are true, then I'm definitely telling a lie, right? Okay, so let's make some observations, just like we did with the and statement. And I'll also give you another vocabulary word. An or statement only requires, well, let me say it this way, requires one or both statements to be true in order to yield a value of true for the or statement. So the only way it's going to yield a false is if both pieces are false. And by the way, quick vocabulary term, an or statement is called a disjunction. Disjunction. Okay, let's talk about the final way to combine two statements, which is the if-then. So let's consider if P then Q, which remember is written as P arrow Q. You can read it as if P then Q or P implies Q. Let's start with the truth table. Alright. P Q, P implies Q. Okay, I'm going to write all my combos over here. True, 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 false, false, true, false, false. So always, when you're starting with two unknowns, or two variables, these are the four combinations. And I suggest writing them in this order, just to keep yourself from getting confused. Alright, so I'm going to do the same thing here, but this, well, let's see. Okay, so I want to write two different statements for P and Q. I want to reestablish what these are, because I think the ones I picked before can be a little confusing for this kind of example, and this is a really important and very non-intuitive way to combine, or a truth table. This is the least intuitive. So let's let, just for the sake of example, P be, it can be it is raining outside, that's fine. We'll just say it's raining. Imply that it's outside, of course, right? And let Q be the car is wet. Okay. Of course, the car is outside, right? So let's not get weird about like where the car is. The car is outside. So P is it is raining, and Q is the car is wet. Alright, so I want to take some time with this. Let's do it like this. Let's get two pieces. Alright, scenario 1. It is raining. So it's true that it's raining, and the car is wet. And then the statement is, if it is raining, then the car is wet. So if both of these are true, and I look outside and I say, if it is raining, then the car is wet, like a robot, right? Like, who says that? But I would be telling the truth, right? I would be telling the truth, because both statements are true. This happened, then this happened. Now, what if I said that it is raining, okay? Or what if the scenario is that it is raining, but the car is not wet? And I said, again, I made this statement again, like a robot, if it is raining, then the car is wet. But I'm not right? Because I said it's raining, so then the car should be wet. But it's not in this scenario. So in scenario 2, where the second statement here is false, then I have told a lie, right? You can look outside and prove it. Like, somehow the car's not getting wet, right? So I've told a lie. Okay. So far, that's all good. Kind of making sense, hopefully. Kind of intuitive so far. Now this is where it gets weird. Okay. It is not raining, but the car is wet. So this is scenario 3, row 3 here. Okay. It is not raining, and the car is wet. So you look outside, it's sunny, it's not raining, but the car is wet. And then I say this statement, if it is raining, then the car is wet. So, have I told a lie? As far as you know, if you look outside, and if I said, if it is raining, then the car is wet, then have I really, have I really told a lie if the car is wet for some other reason? Like, what if you're cleaning it outside, and the hose is on, and the car is wet because of the hose? Does that mean that this statement is a lie? No, it doesn't. And if it's not false, then it has to be true. It has to be true. Okay. Alright. What about scenario 4? I'm going to talk more about these, but 3 and 4 kind of go hand in hand. So I want to get 4 out of the way, and then we'll discuss this more. So 4 is both are false, so it is not raining. And the car is not wet. And then I look outside, so it's just sunny day and the car is dry like a normal day. And I look outside and I say, if it is raining, then the car is wet. Well, I didn't lie, right? I didn't lie, so I've still told the truth, because there's only 2 options, true or false. Okay. These are both true, even though this last one may seem more intuitive to you. This last one may seem more intuitive. They're actually both true for the same reason. They're both true because the first part of this statement is false. It's called vacuously true. They're called vacuously true. Okay, so I want to give some more examples of vacuously true statements. Let's say, the scenario is, this is one I found on the internet, if you're in a room full of people and no one has cell phones. So the scenario is, no one. So somehow no one has a cell phone. Then the statement, if there is a phone in this room, then it is turned off. This statement would be considered to be vacuously true because it's technically correct. It's like, vacuously true you can think of as being like technically, annoyingly correct, right? Because there are no phones in this room. So of course you're right. You could say anything about the phones in this room if there are no phones in the room. You could say, if there is a phone in this room, then it is purple. You would be right because there are no phones in the room for you to be wrong. So this is coming from the fact that there's only 2 possibilities for a truth value in a statement, right? There's either true or false. So if you aren't wrong, then you are right, right? That's how logic works. Of course, in everyday life, there's a bit more gray area, right? But let's see if I can come up with another example. How about that gas station one? Let's say you are buying a candy bar. Okay. Let's say if you hand the cashier money, then he or she will give you the candy bar. Okay, so consider these last 2 possibilities on the truth table. Let's say you go up to the cashier and you don't hand him money and he gives you a candy bar. Then this statement is not false, right? Because this statement only has to do with once you hand the cashier money. Anything before that happens, this statement has no control over. So if I tell you to go into the gas station and I say, if you hand the cashier money, then he's going to give you a candy bar. And you walk in and the cashier hands you a candy bar. I didn't lie, technically, right? I didn't lie, technically. The only way I could have lied is if you walked in, did hand him money, and then he didn't give you the candy bar. Then what I told you would have been a lie. But if anything else happens, like you don't hand the cashier any money, so if you don't satisfy this first condition, and anything happens after that, it doesn't matter what happens after that. Technically, I'm not wrong, which means that my statement is true, simply because I'm technically not wrong. Okay. That is the truth table for conditional statements. So let's go and write down that vocabulary word. Oh, well, first let's make an observation. An if-then, or you can also call them a implication. So these have several names. Statement. An if-then or an implication statement, let's say it this way, is only false when the first condition is true, or first variable, whatever, is true, and the second is false. So in that truth table, you can think of the first situation where both conditions are true. So if you hand the cashier money, then he hands you a candy bar, that's true. That's like the nice way of getting a true out of an if-then statement, right? The others, so that, well, then there's the only way it can be false, which is when you hand the cashier money, but he doesn't give you a candy bar, right? That's the true false. That would be a false. And the others are just vacuously, technically true. Okay, and also, I'll just say it this way. These statements are called conditionals. These statements are called conditional statements. And that marker is dead. These statements are called conditional statements. Alright, let's get into some examples now. I'm just going to go right from the notes here with example 1. Example 1 is, okay, make a truth value, or truth table, sorry, make a truth table for each compound statement. So remember, a compound statement is just two statements put together, stuck together with some kind of symbol. Part A says A or not B. Okay. So this is different. We know how A or B works, but how does A or not B work? Okay, here's how you're going to do it. Anytime you have a negation, you're going to want to, first of all, you make two columns, one for each variable. And if you've got any negations, they each get their own column. So that means I've got a negation of B, it gets its own column. Alright. So let me set up my first two columns, all these four combinations. The classic 4, right? Now, what about not B? Well, not B is just the opposite of B. So I'm just going to flip all of these. So this true became false, this false became true, etc. And now I consider A or not B, and I need to know the facts about ORs, right? The fact about OR is it's only false when both pieces are false. Remember the OR, the disjunction statements. So check your notes, look at that table, see it's only false when both pieces are false. But the question is, which columns am I looking at here? Because there are 3. But surely you understand that I am looking at A from the statement and the not B column. So this B column is only relevant in the very beginning, and it's only there for me to get to this column, right? So I no longer really need this column. In fact, you could even, if you don't need B anywhere else in the statement, we can just kind of discard this column because we don't need it anymore. It was only there so we could get to not B. And now we look at these two columns. So true or false, that's true. True or true is true. Here's the false column, false or false, and then false or true, that's true. Following the rules for or, this is the only row that should be false. Okay. What about part B? So it's not A and B. All right. Here's A and B, and then I'm going to give a column to not A. And then here's not A and B. Okay, so I start with my 4 combinations. Now I need to negate A, so I'm going to look at A and I'm just going to flip everything. So it's going to be false, false, and then true, true. So I've negated A here. So I don't need A anymore, because A doesn't come up anymore. It's just not A. Now, you see how these are in different orders here? Not A and B. That doesn't matter for conjunctions and disjunctions. Meaning, the order doesn't matter for ands or ors. You can change the order. So I don't need to worry about these being in the wrong order. Now, it will matter for implication statements, for the conditionals. So we have to keep that in mind later. If we ever end up in a scenario where our columns are in the wrong order for an if-then statement, then we're going to have to redraw our table with them in the correct order. Alright, so here, recall the rules for an and. An and is only true if both pieces are true. So I'm going to scan this and see, this is the only one where both pieces are true. The rest are going to be false, because that's how an and works. Cool. Okay. C is not A implies B. So I'm going to scoot up. Alright. Going to need A, B, and not A. Here's A, B, and not A, and then the final statement. Okay, so my first 2 columns, just the same 4 that they've always been. True, 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 false, false, true, false, false. Now I'm going to negate A, so it's going to be just like part B. I'm going to have false, false, true, true, and then I can go ahead and get rid of A because A is not relevant anymore. It helps to kind of block it out so you don't get confused. But now they're in the wrong order. Now, I can do 2 things here. I can either redraw my table so that they're in the right order, or I can just read them backwards, going this way. Now, so it's just your choice. If you want to give your brain a break, it's going to be easier to just redraw the table and instead of trying to read it backwards. So that's what I'm going to do. I'm going to redraw the table in order. So I've got my not A and my B, and then the final conclusion that I want here. So this column, the not A is false, false, true, true, and then here's true, false, true, false. Whoops, kind of got a little off skew there. Alright, so I remember my rules for implication. The only time it's false is when I have true, false, right? Because true, true is true, and anything where the first part is false is vacuously true. So that means the only one that's going to be false here is this last combo where I have true, false. So that's false, and the others are true. All right. How about D? A implies not B. All right. So I've got A and B and not B. Okay, start off with the same. Now you may start to, skip steps and say, alright, I get it. If it's going to be not B, I'm just going to write these all backwards, or not backwards, but flipped from what they would normally be. But I'm not going to skip any steps here. I'm going to write every column. Here's my not B column, which is the exact opposite of B. Let me go ahead and write this title of this column up here, and I can get rid of B because I don't need it anymore. And now this is actually in order, right? This is nice that the columns are still in the same order as I would read this. So recalling my rule for the implication, it's only false when I have the combo of true, false. So that's going to be that first one right there. And the rest are going to be true, aren't they? This one is true. These two are vacuously true because that first condition is false. Okay. More examples. Example 2. Same instructions. Construct a truth table. Now we're getting into a situation where we have 3 variables. That means that there are going to be 2 to the 3rd rows or combinations. Remember from the very beginnings, that's 8 combinations. So my table is going to be a lot bigger here. Here's how my table is going to look. I'm going to have P, Q, and R. I think that'll be enough. P, Q, and R. But I'm also going to need the pieces from this compound statement. Now, the grouping symbols that you see here, the parentheses, they're going to work the same way grouping symbols did in arithmetic and algebra, where they say, do this before you do anything else, right? They're high priority. So I'm going to need to figure out what Q or R is first. Then that will give me some truth value here, right? It'll be, there will be a bunch of them. There will be 8 true, and they'll all be true or false. And then I'll take that and I'll connect it to P with an AND. So P and Q or R. So whenever you've got a complicated statement like this, you've got to get each piece that you need to do first has its own column. And then the final column. Alright, so what we need to do now is think about what are these 8 combinations that we're supposed to get here. So I'm going to help you out with that. It's the first one, they're all going to be true. Second one is going to be true, true, false. Third one's going to be true, false, true. Fourth one's going to be true, false, false. And then it's just going to be these 4 again, except with P being false for all of them. So it's going to be false, true, true, false, true, false, still not enough room. False, false, true, so, and then all false. Those are all 8 combinations. So there's going to be lots of repeating here, right? Okay. Q and R. Or no. Q or R. This is Q or R here. So, looking at these 2 columns, so just ignore P. Don't cross it out though, because we're going to need it over here. So just ignore it. Q or R. Alright, consider how OR works. OR is only false if both pieces are false. Let me scan this and just find those where both pieces are false. There we go. The rest are true, so I've got true, true, true. Try to keep your table lined up here. You can draw horizontal lines if you want. Okay. Now what I want to do is I want to connect this column, P, to this column, Q or R, with an AND statement. So I'm going to connect these 2 columns with AND, which means I don't need the Q and R columns anymore. You don't have to scratch these out. I like to do it because it just helps me focus on the 2 columns I need. But don't scratch them out until you're sure you're done with them, right? Alright, now I'm looking at these 2, and I know that the rule for AND, so I want to connect these 2 columns with AND. The rule for AND is it's only true if both pieces are true. So I'm going to look for any false. Anything, anywhere I see a false, that's going to yield a false. So that's false, anything that has a false, so all of these are false. And the only ones that are true are these. Cool. Alright, let's do example 2b. P implies Q and R. Okay, so there's my little variables columns, P, Q, and R. And then think about what is the next piece I'm going to need. Look at what's in the parentheses, right? It's going to be the Q and R. Then once I have that, I'll just attach it to P with an implication, so all I need is this last column. Alright. Okay, so I just paused the video and went ahead and filled these in. It's the same 8 combinations that we had in example A. Alright, now for Q and R. Q and R. I'm going to connect these with an AND. It's going to be false anywhere there is even a hint of a false, they're going to be false. The only time an AND is true is when both pieces are true, so there are only 2 that are true here. Alright, now I want to connect P in this new column with an implication, so I don't need individual Q and R anymore. Okay, now I know that for an implication, they're only false when I've got true false. So I'm going to look for all true falses and write a false. Okay, there's one here. There's actually going to be quite a few, aren't there? Now, the rest of them are going to be true, so I guess there are only 3. Because the only time an implication is false is when you have this combo, true-false. Now the rest of them, so this one will be true, and these will all be true as well. And these last 4 are, we would consider vacuously true because this first condition is false. But the end result is still true. Okay, that's that one done. Okay. Example 3 now. Same instructions as the first example. Part A is, what is it? Okay. Not P and not Q, connected with another AND, P or Q. Okay, so this table only has 2 variables, so it's not going to be really tall, but it's got a lot going on, so it's going to be really long this way. We're going to need a lot of columns. Not a lot of rows, but a lot of columns. So here's P and Q. Start with my 4 possibilities. And then, what are the columns I'm going to need? Well, I told you that if something is negated, it needs its own column. So that means not P and not Q are going to need their own columns. Let's go ahead and get those out of the way. That's fairly easy. Just flipping all these truth values for P and Q. Let's see, that's going to be false, true, true. Okay. Now I'm not going to like cross P and Q out because I'm still going to need them over here. Now, what else do I need? I need this parentheses, this little group here, which is not P and not Q. So I'll be connecting these 2 with an AND. I'm also going to need this little group here, P or Q, so I'll be connecting these 2 with an OR to get that. And then the final result, which will be the combination of these 2 connected with an AND. So not P and not Q and P or Q. Okay, so let's start here. Not P and not Q. All I need to do is look at these 2 columns and say an AND is only true when both pieces are true. The rest are false. See how easy it is when you can recall those rules, those hard and fast rules about conjunctions, disjunctions, and implications, which we only have conjunctions and disjunctions in this problem though. Now P or Q, so now I'm looking at these two. An or, a disjunction, is only false when both pieces are false, so that's going to be this one right there, and the rest will be true. Okay? That's interesting. These are the exact opposite, aren't they? It's actually... Are we going to cover that in this section? I don't remember. There's actually a theorem that talks about these two being equal. Or a law, rather. But I think that's next section. That's okay. Alright, now this last one, this last column, which is the whole problem itself, is we're going to take these two columns, these new columns we have, so we don't need these anymore, but I'll just cover them up. And we're going to connect them with an and. An and is only true when both pieces are true. That means all of these are false. Okay, they're all false. Good. How about example B? Okay. P implies Q, or P, or Q implies P. This is part B, right? Q, yeah. So P implies Q, or Q implies P. Alright, let's get our columns. We've got the P column, the Q column, no negations, thank goodness. We're going to have the P implies Q, and we're going to have the Q implies P. And then we're going to have those two combined with an or. Okay, so I'll start with my 4 combinations. Whoops. That's true. Okay. P implies Q. That's only going to be false in this situation where we have the combo of true false. So this is false and the other 3 are true. Q implies P. Alright, so this is one of those times when we could redraw these columns in order, but I think the table is so big that I think I am going to just, for this column, read these backwards, okay, for this column. So what I'm looking for the false one is for the situation where I have true, false, for Q to P, true, false, false, true. Here it is, true, false. That one's going to be false. The rest of these are going to be true. The rest of these are going to be true. Because the only one that's false is when you have true, false. And remember, for Q implies P, I'm reading this way. True, false. The rest are false, 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 true, true, true. Now, I'll connect these two columns, these new columns, with an or. The only way an or is false is if both pieces are false. But I see none of that here. They're all going to be true. A statement where all of the values just end up being true is called a tautology. Because they're all true. When they're all false, that actually has a name too, but I don't know if our textbook mentions it, and I don't want to mention it if our textbook doesn't, because our homework and tests follow the textbook, and I really don't want to deviate. Let me just look it up real quick. Take 1 second. Nope. Okay. It'll remain a mystery. It's called a contradiction, but you don't need to worry about that. Alright. Okay, I'm going to skip example 4. I'm going to skip example 4 because it's just more of the same. I think it'd be a good exercise. Oh, well, actually, I'm looking at example 4b is actually good, so let's actually do part B. I'll skip part A. Oh, example 4b. So this is part B, which is not of A implies B implies A. Okay, this is a good one because we've got a negation of an entire statement here. So only two variables, so just a relatively short table. We're going to have those four combinations: true, 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 false, false, true, false, false. And now we need a column for both A implies B and its negation. So that's how that works. Everything that's negated gets its own column, and if the thing that's negated is a whole statement, then you got to do that column, that own statement as its own column, and then its negation as well. And then finally, the end result. Okay. So first, A implies B. Looking here for the true false, which will give me false and the rest true. Now I'm just going to negate this column. So I'm going to have a false, true, false, false. Just flipping this column, flipping all of its truth values. Now I'm going to combine this column with A. So I want to connect it with an implies symbol, or it's a conditional statement, an if-then. So I need to read it from this to this. So again, I'm not going to redraw the table. I'm just going to read this way, from here to A. So false, true, that's vacuously true. True, true, that's true. That's a legitimate true. False, false, is vacuously true. And false, false is the same, vacuously true. It's another tautology, because all of them are true. It's important that you remember, whenever you're dealing with an implication, you got to read it in order. The order of the implication matters. This, then A. Okay. Now, example 5 and 6 have to do with going from a statement and named variables to a statement with the symbols. So I'm not going to write them all out because that's going to take a lot of time. I'm just going to say, see notes, right? This is example 5 from 3.2 notes, so go read it. It says, use variables to rewrite the given compound statement. The statement is, we will not go fishing, or we will not go swimming. And the two statements, the variable names are, A is going to be, we will go fishing, and B is, we will go swimming. So the statement is, we will not go fishing, so that's not A. Oh, by the way, this is, yeah, okay. This is not A. And then or, which is that symbol, and then we will not go swimming, so that's not B. Okay, easy enough. That's all you needed to do there. Now let's look at example 6. It's the same thing, just a bit more going on. We've got 3 statements now. P is Tom is on the beach. Q is Tom is wearing sunscreen. R is Tom will get a sunburn. And the statement is, if Tom is on the beach, so that's a implied statement starting with P. So if Tom is on the beach and is wearing sunscreen, look, I got ahead of myself because I haven't hit the then yet, right? So it's actually Tom is on the beach and wearing sunscreen. So if Tom is on the beach and wearing sunscreen, that's going to be P and Q, and then the implication symbol, because then comes the word then. He will not get a sunburn, so not R. See how I fell into the little trap there, wanting to start the if P then Q thing, but the implication wasn't done with just P, right? It says, if Tom is on the beach and is wearing sunscreen, then, etc. So you only draw the symbol when the then, after the word then, has occurred. Okay. The then is like a is like a little point for you to note that the second part of the conditional statement has begun. Yeah, those are good. Okay, and then I listed some homework to add to your review for the exam. I've only got 4 problems there. This is an important section though, so look at those 4, and between those 4 and also your homework in Hawks, make sure you're good with this section because it's an important section. And that is it. Oh, almost perfectly an hour. Cool.